Hi, in this video we will discuss about tree traversal. So there are four types of traversal. Traversal means the process of visiting all nodes of a tree is called traversal. Means suppose there is a tree. So when we write program or anything we will do, right? So we need to visit all nodes of a tree. For searching, deleting, we need to visit all of tree. The process of visiting node is called traversal. So we will visit all node on the four ways. There are four ways. We can traverse the tree. So there are two types of algorithms. One is BFS, breadth first search, and second is depth first search. So using DFS, there are three types of traversal, and using BFS there are only one type of traversal. So BFS based traversal. BFS based traversal only Levelorder traversal. Levelorder traversal. DFS, depth first search based traversal means BFS and DFS is data structure algorithms. So in this traversal BFS has been used, and in this traversal DFS has been used. So first is Preorder, second is Postorder, and third is Inorder. So these three traversal had used TFS based algorithms, and this traversal had been used BFS, breadth first search. Let's discuss one by one. First discussed DFS based traversal. So first is Preorder. So in Preorder, what happens? How will we traverse the node of tree? So in Preorder means root will be visited before the both subtree. Both subtree means left subtree and right subtree. So root will be processed before the both subtree, means that's why Preorder means pre means before. So first it will be traversed root node, then it will be traversed left subtree, then it will be traversed right subtree. So means Preorder should follow these three steps order wise. Visit the right subtree. So in Preorder traversal, these all three traversals should be followed, and it should be in order wise. So let's see this tree. So in this tree, what would be the pre-order traversal of this tree? So first I have given visit the root. First is visit the root, means root, what is the data? First it will be print 0. Then visit the left subtree. This one is the left subtree. So how will I process? How will we process left subtree? So in left subtree, we will also process same thing. Root left right. So on that way, we need to print here 1 root left, 3, 4 root left right. Now left subtree had been processed. Now we can go another subtree, that is right subtree. So right subtree is means right subtree also process same process also need to follow by right subtree. So in right subtree, root left right. Six. This is the pre-order traversal of this tree. Now I think pre-order is clear, means root left right. These 3 steps we need to follow in pre-order. Now jump back to post-order traversal. So post-order, its name also mentioned what is the post-order, what is post-order traversal. Means root will be processed after both subtree had been processed. Means after when both subtree will be processed, then root will be processed. So it means first it will be processed left, then root, then right. Means left, root, right. Means I am not writing here subtree. You can understand. Left means wherever I am writing left means left subtree. So in post order traversal, we need to follow these 3 steps. Visit the left subtree, visit the root, and third step is not root, visit the right subtree, visit the root. So in post order traversal, we will have to follow these 3 steps. Now let's see what would be the post order traversal of this tree. So what I have written here, visit the left subtree. So first visit the left subtree. So left subtree is this one. So left subtree, when we process left subtree, then what would be the process of left subtree? Means left right root, means 3, 4, 1, then right subtree will process. First subtree had been processed. First subtree process has been completed. Now we will go for second subtree. Second subtree we will print here left right root, and last means these two subtree process has been completed. Now in last we will print 0. Now we will discuss about this in order traversal. In order traversal. So in order traversal, what would happen? So in order traversal, route would be processed between the subtree process. Between the subtree process means one left subtree will be processed, then root will be processed, then right subtree will be processed. Means between the both subtree, when both subtree will be processed, so between of both subtree process, node will be root node will be processed. So first it will be left subtree will be processed, then root, and then right subtree will be processed. So root, right. So here in name it's mentioned, name also indicate that what would be the traversal of tree. Pre means root will be processed before the subtree. Pre. Post means root will be processed after both subtree. In means between. Root will be processed between the both subtree. So visit the left visit the left visit the root visit the right subtree. So these three all steps need to be followed in order traversal. So what would be the in order traversal of this tree? First it will be processed left subtree. So in left subtree when we will process, then what would be the print node of left subtree? So 314 means left root right. Then we will print root node. Then we will print right. So right will also, we need to follow same thing, means we have to follow in order traversal. So in order, what is happening? Left root right. These all used breadth first search algorithms, and now DFS algorithm has been used by these three traversals. Now we will discuss about breadth first best traversal, that is level order traversal. Level order traversal. So this one is the level 0, this one is the level 1, and this one is the L2. So in this video I will not discuss about level. I have already discussed about levels and tree terminology in previous video. I will comment the link of this video in this video description. So I would like to recommend you just go to previous video for understanding these all things. Label, what is label, what is root. You can understand better. You can understand better after watching this video. So I would like to recommend you please watch my previous video. So in level order traversal, what happen means first it will process level 0, then first it will process level 0, then after that it will process level 1, after that it will process level 2. So it will be processed like that: L0, then L1, then L2, so on. So what would be the level order traversal? First it will be processed level order. So first it will be processed root node. First it will be level 0, then it will process level 1. Level 1 means we will start from left side. We will not start from right side. So level 2, after that when L1 will be completed, then we will come to L2, and L2 we will process from left side. So left side will process 3, 4, 5, 6. 3, 4, 5, 6. These all 4 types of traversal has been used in tree. Now we will discuss about how to write the program of these all 4 traversal. So for these 3 means pre-order, in-order and post-order program, we will write recursion program. So in pre-order what happens? In pre-order means a root will be processed before the subtree. So SOP means system.out.println. So here I have given here means recursion we have used here. So if you want to recursion, basically function calling itself function means function will call same functionality and one base condition will be there. So when base condition will be reached, then means recursion has been stopped. If there will be no base condition, it will it will run infinite loop. So base condition here I have given. If node equal to 1, node equal to null, then we are returning. So means first we are printing this node dot data, means root node, then we are left subtree we are traversing, and then we are subtracting, then we are right subtree we are processing. I will discuss about means how recursion it will print these all things. I will discuss after writing this program. So basically, I am writing here this function, right? So this function will return, means nothing will return, and just it will print data. And this node is basically root. First time I will provide root, and it will do post order traversal. Means when I will use functionality, I will provide root, and means suppose I will pass this provide root, means root I will provide in as a argument of that functionality, and it will process all the nodes of trees. So post order what happen? First left means root will be processed after both subtrays. This will be the, so what happened here, I have written one function, and one function it takes root node as an argument, and it will process all the nodes of a tree. Now right here post order, now I will write here in order. In order traversal. Node null. This is the base condition. I would like to recommend you, here we cannot discuss about recursion more, so I would like to recommend you, please watch my recursion video for better clarity. So here I am node dot left, node dot right I am writing, right? So I also I have made one video, and that title is means how to represent class. So on that video I have already discussed means how to represent binary tree in class, and I have also executed that program. So you can see here what I have written. So in order means it taken this function, in order traverse function, it's taking one argument, that is it's taking one argument, and that argument is root node. So base condition I have written here, node equal to null, then return, and then we are processing left node. First we will process node left node, then we are printing the data, and then we are processing node dot right. Now, so these three of this program, these three the functionality of all the three traversal which is used DFS. Now we will also write main program, main method. Main method we will create one binary tree, and we will get binary tree means we have I have already told you means how to represent binary tree, and in class how will I provide this node data, how will I link these left pointer, right pointer, how will we link, we have explained, I have explained better on this video. So please watch my representation of binary tree video. So on that place I have created one function, that is a static function, and we are using this static function here, binary tree dot get binary tree, So this functionality will give this all binary tree. Now I will call these all three functionality traversal, and in that function I have to pass root, means I have to pass root. I have already told you means I will have to provide only root. If you will provide root, it will automatically process all nodes. On this way we can write program of these all three traversal. Now I will also discuss means basically how recursion will print these all things, how recursion will be processed, and how recursion will print the node of tree. And I also have to explain about Levelorder Traversal program. So first we understand how recursion will print, how recursion will call, and what recursion will when base condition will be reached. These all things we discuss. So let's see this only. Let's see only one traversal. Let's see only one traversal we discuss here. If one traversal we will understand better how recursion will process, how recursion will print, then we will process. Then we will understand. Then you will understand everything in post order, in order, and pre-order. You will understand everything how recursion will process. So in pre-order, I have written here first node dot data, node left, and node dot right. So here you can see here what is happening here. Node dot data printing, correct. Then it's processing pre-order traversal. Pre-order traversal. So pre-order traversal of 1. Node dot left is this one. And again pre-order traversal of right, correct. So here what I have written, node dot data, first it will print node dot data, then function is calling itself. So again function will call left subtree, this is 1, that is 1, and then again it will call right subtree, that is 2. Now pre-order traversal will call it's 3 and 4. Function will call itself until reach the base condition. When function will reach the base condition, on that time program execution has been stopped. So pre-order traversal 1 it will be called what will happen here, system node. So 1 it will be called, first it will call node dot data. So here node not equal to null. So this base condition will not be executed. It will come here. So left root is this one 1. Then we to call pre-order traversal. Pre-order traversal of 3. Then it will be called pre-order traversal of right node, which is 4. Correct. Now this part, correct. Now it will come to pre-order traversal 3 and pre-order, right. Now this part will be called 3. Now what will be the call? System dot out dot print 3. It will call again pre-order traversal of left. So left of this node is null. Null. Now when this null will be called, correct. So I have written here node equal to null, we will not return anything. So first it will be, first it will be print 3, right. Then it will call pre-order traversal null. If null will be there, we will not return anything, nothing will happen. Then I will call pre-order traversal of again null, means left subtree and right subtree null. again we'll call, and it will not return anything. Now this part has been completed, means this part of has been completed. Now we will go to right part. Right part is this one, Postorder Traversal. Right part of we will process of this one. So this one also system.out.println 4 and pre-order traversal of traversal null. Pre-order traversal null. Now so you can see here, first it will be print 4, then it will be null. When node equal to null, return, means base condition has been reached, so it will not returning anything. Then again we will process right child of this one, it's also null, then we are not processing, we are not returning anything, only print 4. Now pre-order traversal 1 is completed. So first 3 4, right? First it will be print node.data, because I have written here node.data and then node.left. So first it will be print 0. This is later part. So first it will be print node.data, right? Then we will part this one, this root, means this part I will process, means pre-order traversal of 1 I will do. So pre-order traversal 1 will be the pre-order traversal what I have given 1. First it will be print 1. Then what is happening? 3, what's happening? Means it's only printing 3. After that it's not doing anything, means not returning anything. So only printing 3, right? And pre-order traversal of 4 also doing only printing 4. Now our left part has been completed, means this part has been completed. This part has been completed. Now this part we have to process, right? So 2, what we are doing here, first we are printing system.out.println node.data, then we are calling pre-order node.left, pre-order node.right. Now here you can see here node.data. So first it will print 2, then we have to process this one. So pre-order node.left means it is 5 and it is 6. What we have to give here? Now system.out.println, right? Node.left means node.left means we have to print 5, and then we have to 5 left and right both are null. Then pre-order null. Null. So pre-order null, when it will be a, it will nothing. First it will call 5, so print it will be 5, and then this is not doing anything, this is not doing anything. Now this one part completed and this one is completed for that subtree. Now this one part is remaining. Line 6. 6 left and right, there is no child of that node. So this one will be print 6. It's also not doing anything, it's also not doing anything. Now our this part is also completed. Now this part is also completed. So this one with the pre-order. The same thing, the same recursion, the same way, those all recursion program also happens in the same way. So in one I have explained, other you can understand. I am hoping other you can understand better after understanding this one. Now I will discuss about Levelorder Traversal program. So one thing I forget here. So these all 3 programs time complexity will be big O of n. N means number of nodes. Means basically what we are doing, we are going to all nodes. So whatever means how many nodes will be there, on that much time it will be processed. So I am also I would also recommend to you guys. I have made one video which is on time complexity and space complexity. Please watch that video so you can understand better about what is time complexity and what is space complexity. Space complexity will also be ON. Because we are also taking a space, whatever node is there, means how many nodes are there, that much space we are taking. So space complexity is also big O of n. Now Levelorder traversal we will write here. Levelorder traversal. I will also provide a root node here. So Levelorder traversal, what means, there are 2-3 ways for writing program of all the traversal. So as of now, the program which takes big of n and space complexity is taking only big of n. So that program I have written here. I am giving you for practice purpose. You also comment other approach of writing these all programs traversal. So level order traversal, what will you do? We will create one queue. So how will I do level order? What happens? Every level, first we will print level 0, then we will print level 1, and then we will print level 2, right? So what we will do, first we will in queue I will store this root data, right? Root data. Then what we will do here, first we will store root data. So when we remove this 0 from that queue, if we will remove the queue, then we will here print. So if suppose if I remove the queue 0, then we have to take this node in this queue, means left node and right node I have to push in this queue. Means suppose if I remove parent node from queue, then I will also have to add left and right node of in queue. So one node, parent node will remove, and left node and right node will be added. So here when I remove 0, then left and right node of this parent is 1 and 2. So 1 and 2 will be the pushed in this queue. So queue, the node which is pushed first, that node will be removed first. So this node, suppose this node has been pushed first, then first it will be removed this node. So here now order wise 1 is pushed before, so 1 will be removed. So when 1 will be removed, then what the left and right node of this node we will push here. So 3 and 4 I will push here. If I will remove 1, then I will print here, right? Now we will remove 2. So 3, 4, 2, 5, 6 are there. 5 is 6 is there. So in this way, now 3 I will remove, but 3 there is for 3 there is no child, so no need to enter any node. Just we have to print here. Then we will have to process this 5, 6, 4. Then we have to process. We have to remove 5 and we have to print 5. Now we have to remove 6. Now queue has been empty. When queue will be empty, then our level order traversal has been completed. So what we have to do here, we'll create one queue of node queue new linked list. So I'm writing, so in this data structure algorithms, I'm writing program in Java. So if you guys are not aware about Java, then you can, whatever language you are aware, just you write on that language. So first I will q dot add, I will have to root, I have to add, right, and we have to process this queue until it's empty. When node q dot empty, yes, node q dot empty, when there will be data in queue, only that much time this loop will be processed, and when then loop will be processed, what we have to do, we have to remove this first one. So first one, if I remove, so there is a functionality in queue, that is q dot poll. So poll functionality will remove the node which is inserted before, means the node which is inserted first, that node will be removed first, right. Now I will system.out.println temp node use. Now if temp node dot left not equal to null, means if there is a child, then means we will add child on that queue, temp node dot left. If temp node dot or right not equal to null, then q dot add right. So this one is the Levelorder Traversal program. So on that manner we can, we will also execute whatever function we have written here, we will execute in